Assalamu alaikum. Hi everyone. In this video, I would like to share on how to build the bisection algorithm using Matlab programming. In this example, I'm going to solve the extinction angle or the roots that emerge from the problem of rectifier with resistive and inductive load that can be referred to this textbook, Daniel Hart, page 71. That also can be referred to the slide on your left hand side. So to know the detail on the how we derive this function, please watch my video on solving the extinction angle and boundary points that can be found in my channel. Okay, before I go into detail on the Matlab programming, let me explain a little bit on the concept of creating function in Matlab. So there is one way to create a function which is known as function handle. As an example, if I want to write f(x) equals to x squared, I can write in this manner, f equals to, and then use the symbol add, and then put the independent variable inside the brackets, followed by the description of the function, in this case x squared. So I have f(x) equals to x squared. I can also create the second function. For example, g x equals to, let's say, sine x. So I write gx equals to sine x. Now I have two functions, f equals to x squared, g equals to sine x. Okay, it was to be noted that this variable x inside a function handle does not interfere with the same symbol inside another function handle or anywhere in the programming, because it is like a local variable that's only used to describe the function. As an example, if I write f 3, and of course I will get 9, so I hit enter, I get 9. And also when I write g, let's say pi over 2, so sine pi over 2, we know that it is equals to 1. So if I write somewhere else, I want to use the symbol x, let's say equals to 10, okay, it does not affect both function f and g, because as I mentioned just now, x inside a function handle is just used locally to describe the function. I can reuse the function f with another value, and I get f5 is 25, because 5 squared is 25, of course. Okay, let's get right away with the Matlab programming for the bisection algorithm. So I click new script here, and then I want to name my file with bisection, and then I have to ensure that it is appear in the current folder, okay, which is good. And then I normally begin my coding with this statement, clear, and then clear screen. Okay, based on this textbook, Hart, page 71, I obtain all the values for the constant r, l, and omega, and I list them down here. R equals to 100, L equals to 0.1, omega, so I use W equals to 377. All these three quantities are given in the textbook, and then you can refer to the formula of the constant inside the equation, which is theta and also tau. So I want to write theta, so let me use symbol Q. So Q represent theta, is inverse tangent omega L over R. So inverse tangent in Matlab is ATAN omega L over R, and then tau. So I want to use what kind of symbol? what symbol? T is not really good because T normally refer to time. So let's use what? U. U stand for tau equals to L over R. Sorry, big R. And then we can describe the function. F beta equals to sine beta minus theta plus sine theta times exponential power negative beta over omega tau. So beta is the extinction angle. So I wish to use other symbol to represent beta, so I use X. So I can describe this function. Fx equals to sine x minus theta, which is q, plus sine theta, which is q, times exponent power negative beta, which is x, divided by, write a bracket, omega times tau. Tau is u. Okay, so let's run up to this line and to see what do we get so far. So basically the function handle is already appear in the workspace. So far so good. Next we can proceed with the bisection algorithm. So let's write some notes here. Okay, to know the detail on the bisection algorithm, please refer to the previous video lesson. So here is the bisection, and then there it is. Okay, focus on this line, step 1, 2, 3, 4. So bisection method require a bracket. So to know the initial bracket that can be used, we refer to this slide. Sorry. Yes. Okay, let me zoom this graph a little bit. As can be seen here, beta lies between pi and 2 pi. So one way you can say that the initial bracket is pi until 2 pi. I can also use a smaller bracket because I know that beta should not be greater than 1.5 pi in this case. But sometimes it can happen. But in this case, I'm pretty confident that beta cannot be more than 1.5 pi. Okay, so I use A, which is the lower bound of the bracket, pi, beta, the upper bound of the bracket, equals to 1.5 times pi. So this is the boundary of the initial bracket. So we know that after defining A and B, we have to find the middle point between them. But before that, let's specify two important quantity for this iteration. The first is the epsilon that corresponds to the stopping criteria. How small the quantity of the function such that we can stop the iteration. And secondly, we have to put the maximum number of iterations. So I write max iter, stand for maximum iteration. So if the program cannot find the solution, at least it will stop at the 50th iteration. You can also use maybe 100 or more maximum number of iteration. Okay, and then I think we can begin with the main algorithm for the bisection method, which is the main content of the program. Okay, so we have this algorithm. First, we have to define A and B, which we have done, and then find C, which is the middle point between A and B. And then, if the function fa times fc less than 0, so we set the new upper bound of the bracket, which is b equals to c. Otherwise, if fa times fc greater than 0, the lower bound is set as c. And then if these two conditions is not fulfilled, meaning that one of a and c, either one of a or c is the roots. Alright, so we have to decide what loop that we can use. First, you can use for loop. You can write for I equals to 1 until maximum number of iteration, which works. But in this regard, I like to use while loop because for me it is more convenient in this particular case. So I write while 1, which stands for forever, loop forever. But of course, fear not, because we can specify a few breaking conditions so that when the breaking condition satisfied, it will get out from the loop. Alright, so let's write this formula. First, we have to define C is the middle point between A and B. So C equals to A plus B over 2. And then we have to specify these three quantities, FA, FB, and FC. So I want to write FA as the function of A. So I introduce the second symbol, FB equals to the function of B. And thirdly, FC is the function of C. When we write a function and then followed by a bracket, it refers to this function that we have specified in line number 6. So A will be substituted into X as well as this and this. Alright, so remember these two quantities that we have defined in line number 10. So they are used to state the breaking condition. So at what condition we have to stop the computation and get out from the while loop. So the condition is if FC, or the absolute value for FC, because FC can also be negative, is less than epsilon. Okay, this statement means FC is very small, such as it is less than this quantity, which we can say almost 0. So if this satisfied, we break the computation. We can decide that C is the roots. We can also we also have to put the second criteria, the stopping criteria. What if the roots, the program cannot find the roots? So we put if the number of iteration already reached the maximum iteration, so stop the computation. So we have to introduce one value. So in this case, I want to use I. So I start with I equals to 0 here, and then towards the end of the program, I want to write. Before I forgot, let's write down here I equals to I plus 1. You know, I will increment by 1 every time one loop is executed. So I write here, if this satisfied, so this double vertical line means or I greater than maximum number of iteration. So break the loop, break the while loop, and then end. So this is one way how this forever loop can be break. Okay, now let's get into the bisection algorithm. We already described line number 1 of the algorithm. Now we are going to describe line number 2, 3, and 4. So it is as simple as using the if statement. If fa times fc less than 0, b equals to c. Then line number 3, else if fa times fc greater than 0, a equals to c. And finally, else, that corresponds to line number 4, else if neither second nor the third condition satisfied, we break the loop and end. So this end corresponds to this if statement. And we can remove the empty space down here. Okay. Alright. And then we can end our while loop. And this end corresponds to this while. Alright. Now we have done with the bisection algorithm program to solve the roots for this equation. Okay, let's check with our command window. So if I run this program, so as can be seen here in the workspace, I get the final value for A, B, and C is like this. A equals to 3.5005, B is this 3.5036, and C equals to 3.5021. So C is in fact the solution of the function fx. So if you want to test, you can write fc and hit enter. So fc is very close to 0, in which the value is 7 point something times 10 power negative 5. Okay, by the way, we always wish to create some like table looking results that show the list of values of the iterations from the initial guess until the final value, or the points where this while loop breaks. So to fulfill that, we have to write the fprintf statement inside this loop. So after this line, we can write fprintf. So the quantities that we want to display is, of course, first I, second A, and then B, and then C, and then FA, FB, FC, meaning that we have 7 quantities that we wish to display. So we have to describe the formats for I. So I is the integer or natural number. So the format that's suitable for I is D. That stands for decimal, I guess. So give two digits for I, and then we want to specify A. Let's use maybe 10 digits. So A is the floating points. So I want to use the same format for B, and then C, and also F, A, FB, and FC. So this is for I, this is for A, B, C, FA, FB, and FC. And then \n for enter to the next line. Now I list all the quantities that I want to display: I, followed by A, followed by B, and C, and then FA, and then FB, and then FC. Okay, so let's rerun the program and see what do we get in the command window. As can be seen here, these are the results. that we obtain. So the first column, the leftmost column, corresponds to I, and then this is A, B, C, F A, F B, F C. Maybe we can put some header to describe each column. So for doing that, you can copy this and then put it somewhere, maybe here. Adjust it a little bit, and then if you want to put the header, you have to write the string for this symbol, and then we have to change this to string instead of the quantity. Put the inverted commas between them, and also don't forget to change the format. So these no longer numbers, they are strings. So put S, and all of them are string. Okay, let's rerun this algorithm and the header appear. If you want to get more nicely, you can put some bracket here, you know, and also maybe subscript I, but that is just optional. Okay, let's inspect the results. As I mentioned just now, C is the results, in which the value of the function fc is this, which is very close to 0. If you want to get you know, the roots that almost 0, you can change the stopping criteria. So instead of using 0.0001, maybe you can make it smaller, 0.5. So rerun. So now the iterations increase, but you see when C is 3.5022, the value of function is 0 with some negative because there is some small quantity. If you want to check the detail, you can write fc and hit enter. So this is the value when when C is substituted into the function f. Okay, so that's all for now. Thanks for watching.